Welcome students. Here the question is, without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or a non-terminating decimal expansion. Here I have taken this example with a purpose. My purpose is that here we are not taking a standard form in the numerator and denominator. You can see that 91 upon 875, when we are doing the prime factorization of the denominator, we are getting 3 5s and 1 7. Similarly, in the numerator, it is the product of 7 and 30. Hence, there is a common factor both in numerator and denominator, that is 7. This common factor will get eliminated. But what happens during exams, I have found in the when I am checking the paper, I found that usually students are writing this as it is a non-terminating decimal expansion. Why are they misunderstanding it? Because on seeing in the numerator number 7, they are not uh, taking the prime factors of 91. They are simply writing in the numerator 91, but they are taking the prime factors in the denominator. Now what happens is, like this they will start writing. This way. Now here is the big mistake which they are committing. This is usually what I am seeing in the papers. Now see, 7 is hidden in this number, but they are not finding it out, and they are feeling that this is not of the form 2 power m and 5 power m, and hence they are writing it is a non-terminating decimal expansion, which is the great big mistake which they are committing. Now let's move further. So on converting this into standard form, we get 13 upon 5 cube. Here the denominator in the standard form is having 5 cube, whereas when it was not in the standard form, it was having 5 cubed into 7. Now once it is converted into the standard form, we see that as in the denominator is 5 cubed, it is of the form 5 power n. Hence the decimal expansion of 91 upon 875 is terminating, because as the theorem says that theorem 1.5, 1.6 and 1.7, altogether they say that the denominator must be of the form 2 power n or 5 power m or 2 power m into 5 power n. So because of these theorems, this decimal expansion is terminating. Here you can see that I have taken the prime factorization of both the numbers 875 and 91. It is always safe to take prime factorization and then to write, instead of just writing the numerator as it is safer to do the prime factorization, because then only we realize that there is some common factor and we eliminate it. Now the second question is, I have taken the same example and now I am going to convert it into a terminating decimal expansion. So how to do it? As we know that the standard form of 91 upon 875 is 13 upon 5 cube. Now we need 2 cube. Now why do we need 2 cube? Because we want to convert it into the multiples of 10. Now for getting a multiple of 10, that should be two prime numbers, 5 and 2. 5 is already there in the denominator. We need 2, so we are multiplying it by 2, but be careful, the powers should be equal. Whatever is the power of 5, the same power will be given to 2, so 2 will have also the same power. 5 cubed is there and 2 will be cubed. Now according to the rule of equivalent fraction, the 2 cubed will be multiplied even in the numerator. So numerator and denominator are having 2 cubed divided by 2 cubed. Now what is 2 cubed? It is 8. And 5 cubed is 125. So 125 into 8 is 1000. If you don't want to take that way, you can even take 5 into 2, 10, and then keep the common power. The power will be common for both, and that is 3. This is the rule of powers and exponents. In the numerator, you get 13 into 8, and that is 104. And this is very simple to convert it into a decimal number. It is 0.104, which is our decimal expansion. So the same number we have written in the decimal form. Here there are certain real numbers having decimal expansions. In each case, we have to decide whether they are rational or not. And further, we have also to form if they are rational and of the form P upon Q, because all the rational numbers are of the form P upon Q, then we have to say about the prime factors of Q. If, as we know from the previous examples, that if they are rational, then Q will be of the form, if they are rational and terminating, not non-terminating. If they are terminating decimals, then Q will be of the form 2 power n into 5 power m. Here you can see one example. You can convert this decimal expansion into a rational number, and in this rational number we can see that there are 9 numbers after decimal, so we have written 9 zeros. So 2 power 9 into 5 power 9 is in the denominator, and hence we can write, since the denominator is of the form 2 power n into 5 power n, this decimal expansion is terminating according to the theorem 1.5. Here is another example. You can observe that here the number after decimals are not repeating. 1 to 0, then 1 to 00. It means they are not repeating. 1 2 is repeating, but see the number of zeros, they are keeping on increasing. It means they are not repeating. Again, there is a dot dot dot, means they are not terminating. Non-terminating and non-recurring decimal expansion is there. So it will not, it will, the denominator, whatever the denominator, according to the theorem 1.7, the denominator has the factors other than 2 or 5. It means it will have factor 7, 3, whatever it will be there, other than 2 and 5. Maybe 2 and 2 into 5 will be there, but then again it will be multiplied by 7, 3, or any such number. Hence, it cannot be represented in the, means it is not, it cannot be represented in the form P upon Q. It is an irrational number. Non-terminating, non-recurring numbers are irrational numbers. And here we are having an example 43.123456789, where you can see the bar is after the decimal point. It means from 1 to 9 the numbers are repeating. Now here when you are seeing that it is non-terminating, the bar says that this decimal expansion is non-terminating because 1 to 9 all the numbers keep on repeating. That is the meaning of bar. When it is non-terminating, it means the denominator will be not of the form 2 power m into 5 power n, but it will also have the factors other than 2 or 5. Hence, it is a rational number, but it is non-terminating, repeating rational number. Thank you.